Hello, I'll try and make this one rather quick. I'll be looking at the Great Pyramid, which this also applies to the other pyramids, the largest intact ones, and the use of the Egyptian Royal Cubit. Now, I've covered it many other videos, but how the cubit, the Egyptian Royal Cubit, the meter, and the second apply together. So, for instance, as was the case for a very long time before the modern definition of the meter was originally a unit of time, and you would swing a pendulum 30 degrees in the total arc, or 15 degrees from standing, and that was how you would calculate a second. So 1 meter and literally describes a second. That was the origin of it. Then it later came to be based on the definition of Earth, the polar circumference of the Earth, and now we connect it to the speed of light in this. Yeah, that's a curious thing on its own. But if you swing a pendulum at 30 degrees, 1 meter long, the arc will be pi over 6 meters. That will be 0.52399. I've just rounded off to 5.236. So I'm rounding things off at like a fraction, less than a fraction. Actually, well, not less than a fraction, a fraction of a human hair. But just an intro, because I'm going to do a couple other videos to follow this up to show that the cubit is. It's often said that the cubit is exactly pi over 6 meters based on the Great Pyramid, but using the actual survey, you can find that it is actually not. There is not a single on all four sides are slightly different on the pyramid, and not one of them is exactly 440 cubits times pi over 6 meters. So this is often described as the case, but still there is a very strong connection between the cubit, the meter, and the second. And now also you'll find this. So Niels Bandholm, and he's talking here about how, again, his legacy. So for instance, the northern foot, which is equal to the Indus foot, and how there's a legacy of ancient connection of ancient measures seem to, especially through to Western and Northern Europe much later. But there's an interesting little paper here. You can just do a search to find it, and how the Norwegian measures 52.3 centimeters. But okay, I'll leave that to the side for the moment. But there again, just as an example, we see the pendulum, the 30 degree is the swing, because if you swing it further than that, you a bit like when you go on a swing, there's like a drop. If you ever, when you were a kid, if you swung and you get to a certain angle, you can feel the drop. It's not. So that's one reason why 30 degrees is important, because if you go extend it over there, you start to get, you lose the second. Now the weight of a pendulum doesn't matter; it's the length that counts. And so, but 1 meter pendulum swung 30 degrees gives you 1 second. That length of arc is pi over 6 meters, or pi over 6 radian, which is 30 degrees equals pi over 6 radian as well. It's a nice little link. Egyptian Royal Cubit, very close to E minus 1. Again, we can get closer to that, but I'll do that in follow-ups. But for instance, if you draw a hexagon, which the flower of life, for instance, if it's a 1 meter diameter, because the radius of the circle is equal to the edge length of the hexagon. So the edge length of the hexagon is 50 centimeters, or half a meter, and the arc is pi over 6, 0.23987. So we have, you can call it a two-dimensional connection, like the hexagon in the circle. Again, if you draw the flower of life, hexagon is just this perfect shape in nature. That's why bees and use it. The radius of the circle is equal to the edge length of the hexagon. Same thing. Okay, but there's a few more. Now, for instance, we have the hexagon. Now, a circle and a hexagon. Now, a hexagon is almost, it's like a two-dimensional representation of a three-dimensional cube, and this 0.5236. I'm just going to round it up. 0.5236. Just, did I get the right number? Yep, okay. But this also applies to the third dimension. So what we had was the hexagon, like a two-dimensional representation of a cube within the circle. but we also have, so there, if you tilt the cube, you see it's hexagonal, not perfectly because of perspective. But so a cube, now a sphere inside a cube has a ratio of volume of pi/6, the same number, 5.235987. So two-dimensional and three-dimensional. So we get an example of what I mean by that. But the pyramid itself, one of the proportions built into the pyramid is, and you need to go to the north west to find this. Each side of the pyramid is slightly different. Each side of the pyramid has usually the phi ratio is usually depicted based on ideal measurements, and they're very, very close to pi and phi. But if you use the most accurate measures, you'll find that this little discrepancy between this actually resolves itself. But for instance, on the northwest corner, the half base to the from the peak to the corner, including the socle, the socle of a paving stone gives it a slight bit of extra height, and this isn't usually included in there, but if you do, you actually, now we get this ratio. Now that's based on the measures. Now, again, within a fraction based on the information that is available, but again, if you add if you're splitting hairs, the number actually gets resolved to 0.pi/6, and that's what we have. And it's interesting because this is a three-dimensional and two-dimensional relationship. Well, so we have the base, but we have to include the socle, and that now adds a third-dimensional aspect to this as well. So that's a nice tie-in. But remember the cube and the sphere. So the cube is a three-dimensional square. The sphere is a three-dimensional circle. Okay, so we've seen those. Now it's interesting that the pyramid itself is ever so slightly south of 30 degrees. Now, without going, if you include some other, well, the three pyramids of Giza are aligned to Heliopolis. Heliopolis is exactly at 30 degrees. If you stand on top of the Great Pyramid, again, it becomes 30 degrees. It's got to do with, again, some details in how we do measurements and stuff. But again, so it's 30 degrees, or pi/6 radian. That's how far north of the equator it is, and 33.333 radian. 30 degrees is 1800 minutes, or 108,000 seconds on the compass. So there you go. So the cubit, the pendulum, the metre combined, the position of the pyramid north, and also described by radian, the three-dimensional aspect and the two-dimensional aspect around this number pi/6, or 0.5236 meters, is one Egyptian Royal Cubit. Okay, so that's done. Now, but here's the kicker. So we've already seen, so if you use the half base, now from the center, but I also showed you could use the half base on the northwestern face, and the pinnacle to the corner, including the socle, gives you this proportion which describes how many meters is the Egyptian Royal Cubit. But also it's being described in the pyramid itself. Everything that connects back in. What's on the outside is also on the inside, as above, so below. And the King's Chamber, we've got some info in there. I'll do that in the future. Got to revise got some new info in regards to the King's Chamber and the geometry in regards to there. So the sphere and the cube, the circle and the square. Okay, so now we saw that's the same, the north. Okay, I think I've got a typo there. That would be the northwestern corner. So that's what I'm looking for. Have I got that correct? Either way, that's the northwest corner. Sorry about that. Northwest, not the northeast. But what we have is this 0.5236, which is the ratio of a sphere in a cube, three-dimensional. But also on this corner, so from the tip to the very center, and then so you see this cross section, this triangle here, the ratio there is 1.273236. Well, that's 4/pi, which is the ratio of area of a circle in a square. Here we see the ratio of volume of a sphere in a cube. A sphere is a circle, a cube is a square, in 3 dimensions, but in 2 dimensions we also get this 4/pi, which is the ratio of area. So 2-dimensional area, circle and square, three-dimensional volume, sphere, and a cube, coming back to, well, this very beautiful set of numbers. And so, as is defined, Egyptian, the base of the Great Pyramid is said to be 440, but each side is slightly different. So I'm just simplifying that for the moment, and that's based on a Egyptian Royal Cubit of pi over 6 meters. However, as I'll show in some future episodes, that is not the actual Egyptian Royal Cubit, exactly pi over 6 meters. It's ever so slightly shorter than that. And if you include this information, then a whole other stream of very important geometry, time, astronomical data, ancient units of measure emerge from that. So 0.5236 pi over 6 meters, the Egyptian Royal Cubit. The second pendulum, 30 degrees, all comes in so together nicely. It all blends into one another, and it's just bloody brilliant. And so by using the as most accurate survey data as you can get, not only does it resolve the issue in regards to the pi and phi proportions in the pyramid to get them essentially as accurate, well beyond acceptable margins of error and problems with measurement, but then it also will include time, just so much information and data in regards to that, and calling this all this on its own, it's like calling a coincidence is, well, without examining it, is a little bit harsh. Now, but when you include all the other information that will emerge from this and how it connects to so many other, the esoteric traditions, so for instance, I'm going to show the Colosseum, the great cathedrals, ancient units of in Greek measurement, such as the Aegina foot, and how we saw it also to the Indus Valley and all these other civilizations. And so that's it, 0.5236. I hope you enjoyed. Have a good one. 2 dimensions and 3 dimensions as well. It's really cool.